All right, here we are. This is going to be the first 20 questions of the final exam, the final multiple choice exam. Uh, let's get into it. Number one gives you the distribution here. And it's just asking you which is the best description of the shape. So it's B here. Bimodal, if you're wondering, again, that just means two modes or two peaks. So I see two of those, one right here and one right here. And the gap it's referring to is that purple gap right here where there is no data. It's not skewed. That's not, it says skewed right. So it's not skewed right either way. Like if you did draw kind of a arc over the top, if anything, I would say that's skewed left. So, and it's not approximately normal. It's not a nice, neat bell curve. Number two, basic probability. You have a table with 103 people. They were asked if they supported um, expanding the public library, and they broke the people up into two different age groups. This is a straightforward probability. Well, not straightforward, sorry. It's got a condition. Which one is the closest to the probability a person selected will be someone who responded no, given that the person is age 55 or older. Remember, the given is the condition, and conditions limit your options. You can no longer pick 103 people. You have to pick one of these 44 people, that green highlighted column. And of the green highlighted column, there are 36 people that voted no. Take your calculator out and divide, and you'll get E. Um, Three, this is a good one. Lots of connections to make here. They collected data on the fiber diameter and the fleece weight of wool taken from 20 sheep. The data are in the following graphs. Graph 1 is the scatter plot of the fleece weight versus the fiber diameter, right here, and with the least squares regression line right here in black. Graph 2 is the residual plot of that. So they're using the fiber diameter to predict the fleece weight. Fiber diameter is the explanatory variable. Fleece weight is the response variable. All right, so it says 1 point is circled on graph 1, this point right here. And then you have these 5 points, A, B, C, D, and E over here. Which point on graph 2, A, B, C, D, or E, represents the residual for this point right here? So remember, residual is, I should jot this down. Residual is equal to the observed value minus the predicted value. Okay, the predicted value is on the line. So for this particular sheep, the dot represents the observed value. So it looks to me like the observed value is 5. And the up to the line right here, this value over to the left would be the predicted. So the predicted weight of the fleece was 10. The observed weight was 5. So the residual, it would be 5 minus 10. 5 minus 10, which is negative 5. Another way to quickly say that is, look, the dot is below the line. It is under the line by about 5 spaces. So this dot has a residual of negative 5. So carry that negative 5 over here. This is using, oh, this is tricky. Look at what's the x value? It is the predicted fleece weight. So for this dot, what was the predicted fleece weight? Well, the predicted weight was the value on the line, which is 10. The predicted weight was 10. So that comes down here and tells you that we're at least limited to these dots, C, D, or E. So we can eliminate A and B. Okay. Then looking at C, D, and E, which one has the correct residual? Well, we just talked about the residual being negative 5, so that comes down to here, residual, and it tracks across and it tells you that it is point C. That had a lot of connections there. All right. This is just basic shape question. Which of the following shapes is not represented up here? So I just named this. This one's bimodal, has two peaks. This is skewed right, this is skewed left. This looks like the normal curve. It's symmetric and it has one peak. The only one that's not represented is uniform. Uniform is if they were all the same, if it was flat. If we all wore uniforms to school, we'd all look, very similar. All right, 5. Probability again. The sample has 1,092 people. They were asked to consider buying a car, whether color was important. They were also asked to identify an additional feature that was important. So, was cost important? Yes or no, or maybe. And then other things like is comfort, cost, performance, reliability, and so on. The question is, which of the following is the closest to the proportion of people who responded no to color consideration and who also identified safety as an additional feature that was important? So the and means you want to find the people that have both of these characteristics. There's no condition, there's no given here. So my denominator is going to be the 1,092. My numerator is the people that did both of these things. So they said no to color. So I highlighted these people. And they said that safety was important. So here's the people that said safety was important. Where did these 376 people said safety was important? So where do these two groups intersect? Where do they have, right here's where they intersect. So there are 192 people that did both of these things. And then divide that and you get 18%. 6, scientists estimate the distribution of the lifespan of the Galapagos Islands giant tortoise is approximately normal. 100 years mean and a standard deviation of 15. So I love to just set up the curve like always. Centered at 100, standard deviation is 15. Based on the estimate, which of the following is closest to the age of the Galapagos Islands giant tortoise at the 90th percentile? So remember, 90th percentile is like this. What is the age, x, we don't know the x, what is the age of the turtle for which 90% of the turtles are younger than this turtle? Or this turtle is older than 90% of all the turtles. So we can do this a couple ways. You can use table A to get the z-score for 90%. It's going to be 1.28, and then you set up value minus mean divided by standard deviation. So I'm going to look up 0.90 on my College Board sheet on my z table. It's not this page because these are all negative z-scores, and you could tell that I had a positive z-score. So I'm looking on here, where is in the guts of it, where is the number closest to 90%? And as I track through this, it looks like it's this one, which is 1.28. So that's one way to get your z-score, okay, right there. And then take your calculator and do your work. So I would take 1.28 times 15 times the standard deviation and add 100. And there you go, 119. So that would lead you to the answer. Another way to do this is if you don't want to mess with table A, you can do the inverse normal button. So under the distribution menu, you can do inverse norm. The area is 90% right here, 90%. This can actually do the whole thing. You can put in the average was 100 and you put in the standard deviation was 15. I'm shaded to the left. If yours doesn't have that left, center, right, it automatically goes left. And there's your answer. It just does it all for you. Wonderful, isn't it? Number 7. Car rental agency has 2 locations. The box plots summarize the miles driven for one day of single car rentals at each location, location A and B. Based on the box plots, which statement is the best comparison for the 2 locations? The number of single day rentals is greater for A than B. The number of single day rentals is less for location A than B. Like what do they mean by the number of? Like this is just two too vague. Like we need to be more specific. Are we talking mean, median, mode? Are we talking IQR, range? This is just too vague, okay? So we need to be more specific. And C, D, and E are, it says compared to location A, the miles driven for B display more variability, less variability. Which one is it? Well, and the median is greater. So now we're getting specific. The medians are the middle of the box plot. So yes, the median is greater for B. So the median is not about the same. So I can get rid of E. So I'm down to C or D. So then which one is it? Does it have more variability or less variability? Does B this have more variability or less variability? Variability is just spread or range. So I did a quick calculation here. The range of this one, it goes from about 10, I just said that's 10, to about 200. So the range is 190. You can also just tell it's just a longer box plot, goes all the way to here. This one I did like 390 to 10. So you can see the range is much bigger, more spread out. So the answer is C. 9, this is a sampling one. For determining the value of its end of year inventory, a clothing store creates a list at the end of the year for every item, every single item. That's called a census. It's not an experiment, you guys. An experiment would be like if they're treating the clothes with, they're not doing anything to the clothes. They're just creating a list, okay, about the clothes to have an inventory at the end of the year. It's not a sample survey because a sample is part of the population. In this case, they did the entire population, every single item. So it's not a sample. So these are wrong. It's a census because all the items are listed. Number 9. Okay, here we go. This is the one about the grocery store that gets corn from Iowa and Ohio. Now, this can be done, believe it or not, without touching your calculator. It says the mean for both farms is 1.26. So I've drawn a curve for Iowa and I've drawn a curve for Ohio. Notice they're both centered at 1.26, okay? And then in orange, it says the standard deviation of the weights of corn from Ohio is greater than Iowa. Okay, then they select a random ear of corn from Iowa that weighed 1.39 pounds. Excuse me, and the z-score, standardized score is z-score. The z-score of 1.645 for that ear of corn. If the ear of corn from Ohio also weighed 1.39 pounds, how many standard deviations from the mean is the weight with respect to Ohio? So I've drawn here on both curves, we have an ear of corn that's 1.39 pounds. So on both curves, it's above the mean, right? So these two that say below the mean, they are not possible. So get rid of A and D. It's above the mean. And then you can think logically here. Look, you really have 3 choices. One, is the standard deviation for Ohio going to be smaller than 1.645? Is it going to be the same or is it going to be bigger? You can just reason your way through this. If the standard deviation for Ohio is larger, then that will make this value will be fewer standard deviations away from the center. So this is the only option that is a smaller z-score above the mean. So the answer is B, if you can just reason through that. Like, what if I said, hypothetically, say, what if the standard deviation was 2 and the standard deviation for Ohio was 4? Okay, just get rid of the awkward decimals. So they're both 0.13 pounds above the mean, right? But this one would be dividing by 2, and this one would be dividing by 4 for the standard deviations. So the Ohio one is going to be a smaller number because I'm dividing by a larger standard deviation. If that reasoning doesn't suit you, you can go through the work, but just know you're going to be taking up test time. So what I did is I used the Iowa information because they gave me the z-score and they gave me the weight and they gave me the mean. And I backtracked and I solved this for the standard deviation of Iowa, and I got 0.079. And then it says, well, look, Iowa and Ohio are related. Ohio's standard deviation is 0.01 greater than Iowa. So that's what I've written here. Ohio's is 0.01 greater than Iowa's. So I now know the standard deviation of Ohio. And then I take the values and I plug it in down here to get my standard deviation. So you can calculate it by hand. It's just going to take you a lot longer. 10. Ooh, this question is a doozy. All right. The distribution of the number of hours worked by volunteers last year at the hospital is approximately normal, with centered at 80, a standard deviation of 7. So I drew my curve with 80 in the middle. Volunteers in the top 20% will receive a certificate of merit. Why did I say a voucher? Will they get a certificate? It could be a voucher. Okay, if we pick someone at random, which of the following is closest to the probability that the volunteer will receive a certificate, given that the number of hours they worked is less than 90? Okay, so I have a lot here. Multiple ways to go about this. So first of all, the people that get a certificate are in the top 20%. This is the green, that light green shaded, okay? The top 20% get a certificate, okay? Then the condition is that you work less than 90 hours. So I put an orange line at 90, and I want to know the probability of that. So how did I do that? So what I'm going to do is use the normal CDF button, okay, to figure out this 92%, okay? So you do normal CDF. You can just type in a extremely low value, like way down here, like 0 hours, nobody worked less than that, and 90 hours is the upper, and then put in the actual mean and standard deviation that was provided and paste that in. So there it is. There's the 92% right here. 92% of the people volunteer less than 92 or less than 90 hours. Okay. Um, so um, you can think about this without even getting into all this if you want. A condition, what does a condition do? The given is the condition. It limits who we can pick. We can only pick people in the lower 92%. We have to pick somebody. There's the bell. We have to pick somebody that worked less than 90 hours. So that's why my denominator here is 92%. Of those 92%, who got a certificate? I keep saying voucher. I don't know why I'm saying voucher. They got a certificate. Certificate. Okay. Not a voucher, a certificate. Okay. Of this 92%, who worked less than 90 hours, only this little red section, only this group right here got a certificate, right? And that is 12.34%. You might be like, how did I get that without doing any work? Well, remember the green part is 20%, okay? The green part is 20%, and I know that this green line, so the green line down would be 80%. The orange line down is 92%. The green line down is 80%. That's right. From here on down is 80. So therefore, if you subtract these two, you're going to get the percentage of the red section, which you'll get 12.34. And that is why my numerator is that. So if you divide these, that is it. That's a lot. You know, so if you want to go about setting it up with the formula, here's how you would write it. This is the probability that you receive a certificate given that the person worked less than 90 hours. That's what this is saying right here, right? So the probability of receiving a certificate given you worked less than 90 hours. And then the formula says, which is on your College Board formula sheet, right here, conditional probability. The condition goes on the bottom, and the numerator is the probability of both of those things occurring in the numerator. So the denominator is just the probability of someone working less than 90 hours, which we talked about. That's 92%. The numerator is the probability of both of these things happening. So they have to get a certificate and they have to work less than 90 hours. So that, again, that is this red section. And I talked about how I found that earlier. You could also use normal CDF to get this red section. If this logic is just eluding you, you can do this. Well, first, I guess you have to know this X. So to do that, you would do your inverse normal button. You're going to put 80%. You're going to put 80 hours and 7, because that is the information of the curve. Okay, and that's where I got my 85.89. Okay, so for somebody to get a certificate and be less than 90, they got to be above 85.89 but below 90. So now I go to my normal CDF, put in my lower and my upper with those numbers. Upper is 90, and again 80 and 7, and there's that 12, 1, 2, 3, 5 number. All right, that was probably more than you wanted on that. Number 11, this is getting at outliers. So we have two groups. We have the 5-number summaries. So you could think box and whisker plots whenever you think of 5-number summaries, okay? The numbers 60, 62, and 84, they were in both groups, common to both samples. The three values are outliers with the young group, the 20 to 30-year group, because they are either 1.5, so they're kind of telling you what the formula is right here. Okay, if you forgot this formula, they are telling it to you right here. Using the same method for identifying outliers, which of these three numbers are outliers for this second group? So we got to get the boundary and then check those three numbers against it. So first, the IQR is Q3 minus Q1. So subtract those and you get 6. Then the formula for the upper boundary is starting at Q3, 76. You add, there's the bell again, you add 1.5 IQRs. And we just found the IQR was 6. So when you crank this out in the calculator, you get 85. So any number above 85 is an outlier. However, 84 is not bigger than that. So we skipped that one. Okay, that's not an outlier. The lower boundary is similar. You start at Q1 and you subtract 1.5 IQRs, which brings you to 61. And 62 is higher than that. So 60 is the only one that's an outlier. 12. This is the study design question. They want to survey a sample of students from the college. From each major, they randomly select 5% of the students within that major to be in the survey. So this is the majors are the groups, and then from each group, you pick some of the people. This is what you call stratified. Systematic, just to go through these, this would be like every 7th person in that major, every 7th student, that walks through the door or something like that. Simple random sample is there are no subgroups. You put everybody in a list and everyone has a random chance of being picked. This is always preferred if you can, Usually, I would say it's usually preferred. Convenience would be, did they make it easy on themselves? Did they like stand at the door and just ask people that walked by them? It doesn't say anything about that. A cluster, now you might have been confused by this one. A cluster is if you pick a major or two, pick say 2 to 3 majors, but then you don't ask some of the kids, then take all students in those majors. That's a cluster. All right. This one shows, okay, this is the population distribution. This is everybody. It has a mean of 85 and a standard deviation of 18. And now it says which one of these is the sampling distribution if we sampled 40 from the population and got the average. So let me show you the College Board sheet. Right here, we're sampling means, okay? And we're sampling one population. And we, come on in, Riddick. And we'll, give me a second. I gotta do this. I'm distracted. Is that the right one? You can pause the video, everybody. Yeah, you don't need that one. All right, sorry, everybody. So it says this is what the sampling distribution looks like. This will be the center, and this will be the spread of it. So it will be centered at mu, and this will be its standard deviation, which I've written written here, right? So the center should be 85 because that's where the population is centered. So you can eliminate D and E because they are not centered at 85. Okay. You can also eliminate A. A is just a carbon copy of the population, and that's not going to be true. Remember, if you take a sample that's large enough, it should begin to look approximately normal, which B does and C does. So it's B or C. B and C are both centered in the right spot. However, their standard deviations are not the same. So I did the quick standard deviation calculation from that formula I just showed you. It said 18 was the standard deviation. The sample size was 40, so 2.84. Okay, so it should be going up and down with a standard deviation of 2.84. Remember, 95% of the data is within 2 standard deviations of the center. So this one, it was just too tightly packed because if the standard deviation is almost 3, then from here, if I went up 3, I'd be at 88 in 1 standard deviation. And question mark, I don't see any data, so it's B. 14. Oh yeah, this one. Okay, they're studying trees and they got a confidence interval from 0.14 to 0.20 to estimate the proportion of trees that are dead, but they're still standing. Using the same confidence level, the interval was revised because the sample proportion was miscalculated. The correct sample proportion, and when you hear that, you should think the correct p-hat was 0.27. Which of the following statements is true? So first off, I looked at the original interval. I just sketched it out right here, and I can see pretty easily that my original p-hat was 17%, and then they raised it to 27%. Okay. So look at the choices. They're talking about the interval being narrower or wider, and they're saying that the sample proportion got farther from 0.50 or closer to 0.50. So the first sample was 17, the second revised sample was 27, and you can see, well, that's getting closer to 50. So it is not farther from 50, so it's not A, it's not C. and it's not going to be E. You'll see why it's not the same width. So the only difference between B and D is, does the interval get narrower or wider? So an interval, the width of it is determined by the margin of error. It determines the width. And this is the formula for margin of error. It's Z star times the standard deviation. Now they have the same confidence level, right? So Z star is not changing. So I don't even need to worry about that. I just need to look at this, looking at both P's and see which one is bigger. So with 0.17 versus 0.27. And if you take your time on your calculator and do both of these, you'll see there's the first one, and then the second one is bigger. So the margin of error has gotten larger, so the interval is wider, right? So this is 0.37, it's less than 0.44. All right, 15. The research organization reported 41% of adults were asked to describe their day, we're having a good day rather than a typical day or a bad day. They investigated whether the percent would be different. For high school kids, they asked 600 high school kids. When asked to describe their day, 245 said they were having a good day. Does it provide evidence that all high school students who respond that they were having a good day is different from 0.41? So I'm just going to run a test, everybody. It's a proportion because it says percent. The null, the given is that it's 41% of adults are happy. The sample was this, and then make sure you do two-sided because it said, is it different? And then we'll get the p-value and it will guide our answer. So stat tests, one prop Z test is number 5. Put in the information. 245 were happy out of 600. Keep it at not equal to. So my p-value is 0.93. That's really high. So that's why the answer is B. The p-value is greater than any reasonable significance level. Yep. Yeah, there you go. And moving on. 16. Director of a rec center conducted a 6-week study to examine the efforts of 4 types of exercise: strength training, flexibility training, aerobics, jogging, blah, blah, blah. On what? Maximum oxygen consumption. From the 40 members who participated, they randomly assigned 10 members to each exercise type. Maximal oxygen consumption was measured. Okay, that's important for each member at the beginning of the day and at the end of the 6 weeks, beginning of the study. The director examined the change in oxygen for each member. Which of the following is the correct description of a feature of this study? Does the study have replication because there's 4 exercise types or because it was conducted over a 6-week period? Neither one is true. Replication comes from having a large sample size, okay? It's not the number of treatments, it's not the length of time, it's the value of n. In this case, there were 10 people doing each exercise. That's where the replication came from. The response variable is what is being measured, which is the oxygen consumption, okay? So the response variable is the type of exercise? No, they were not measuring the type of exercise. They were measuring the oxygen consumption, which you might see it over here and be like, well, that's it. But no, if you read this, this is just a bunch of nonsense. It's the type, are they measuring the type of exercise with the greatest change in maximum oxygen consumption? That's kind of the ultimate conclusion that they would make, but what they're actually measuring is simply the oxygen consumption. D is the answer. The treatments are what they made people do. Treatments are what you tell people to do, and they told them to do strength, flexibility, aerobics, or jogging. So it is D. The units, just to talk about this, units are the people. or the subjects or the objects that you're treating. They are not the treatments. Okay. We're getting there. 17. This is one about roommates that work at the restaurant and they make different amounts of money. Sean makes less money than Evan, it looks like, right? Sean makes 225, Evan makes 240. They both have standard deviations. Assuming their incomes are independent, which of the following is the closest to the probability that Sean will have more income, greater income than Evan in a week? So this one is hard. This is going to be a time kill. What I need to do here is I need to look at the curve for the difference in their income. And this I did Evans minus Sean's because Evan made more money. So Evan made 240 minus 225. This curve would be centered at $15. On average, Evan makes $15 more than Sean. But there will be weeks over here in the green section. This green section represents where Sean made more money, if that makes sense. If Sean made more money than Evan, then Evan's money minus Sean's money would be negative. Because this curve is Evan minus Sean. Okay? So I just need to find this percentage. Okay? So this formula gives me the standard deviation of this distribution. Where do I find this? This is on the College Board sheet. We have two samples. We have Sean and Evan, and here's your standard deviation. And so this is what I'm using right here. It gave me that information for both Sean and Evan. This tricks kids. It is a sample size of 1, so I have 1s here. And then I take the standard deviations here and here. Take your time, crunch this out in the calculator. You get about $29.15. Okay. So this now is a normal curve centered at 15 with a standard deviation of 29.15. Okay. You could get a z-score for 0 by saying how far is 0 from 15 and dividing by the standard deviation, get a z-score. You could look your z-score up in your formula table. You could also do normal CDF a variety of ways. You could do negative 99 up to that z-score, negative 0.51, 0, and 1, like that. That's standardizing it. So there's the answer, about 30%. You could also not standardize your z-score. You could just leave it in terms of money. Again, negative 99 up to 0. Then put in the actual information right here in context. Like that. Either way, you get the same answer. That one is definitely a time killer. I would say if you're like looking for a way to speed it up, like if you can get the standard deviation, then, well, you can see that this is only 15 away from the middle. It's not even a full standard deviation. So I would eliminate A and B, just if you know the empirical rule, the 68, 95, 99 rule pretty well. 18, this is about elections. Only 36% of eligible voters voted in the 2014 elections. So that's going to be your P, okay? For a random sample of size 40, which of the following best describes the sampling distribution of P hat? Which is the proportion of people who voted. So whenever you see describe the sampling distribution, go to your cheat sheet. So this was sample means, but right above it is sampling distributions for proportions, and it would be right here because it's a single sample. So it's going to be centered at P with this standard deviation. So oops, I have the same thing. If so it's going to be centered where the population is centered. So it's going to be centered at 36. So I can narrow it down to A, C, or D. Also, you notice these say it's skewed. It's not going to be skewed because the sample size is large enough. We had 40 people, so did we have 10 successes and 10 failures? That's called large counts. So I took 40 people times 36%. So I would expect 14 people to have voted. That's 10 successes. And then vice versa, 25 people to not have voted. So it is going to be normal because of that. So it's C, D, or E, not A or B. And then it is centered at 36. So it's either this or this. And from the formula sheet, this is the standard deviation of the sampling distribution. Plug in a 0.36 into that and a 40 into that, and you get 0.076. 19. To investigate whether consumption of beetroot juice enhances exercise performance, a researcher selected a random sample of 50 athletes from all students at the college. And it goes on and on and on and on. It tells them what they did. Based on the design, which of the following is the largest populations that you can generalize your results to? Okay. This has to mirror the sample. The sample was student athletes at this college, so that is your as far as you can project your results. Okay. These two are too specific. It's just saying like you're limited to the actual people in the study. That's too specific and too small. And D and E are too broad, too far reaching. Okay, so it's C. One more. This thing, look at that. It's a whole page for one question. You might want to quit right now. Just kidding. It's talking about they want to know what conditions people are more likely to complete and return a survey. And they had three different methods. They gave it to them in class, um, and they were asked to return it to their instructor. Psychology, they were given to them, kids in a psychology experiment. They were asked to return it to a collection box in the hallway. D, the dining hall, give it to them when they were eating lunch and ask them to return it to a box outside the dining hall. Those are the methods. Here's the results for the rate of return. So you can see, just looking at trying to understand this, people that got the survey in class, it looks like, about 50, upper 50% returned it. That's this part right here. And people in psychology, it looks like about half of them returned it. If you're in the dining hall, only about 30 to 35% returned it. So, which statement about the delivery method and the rate of survey return is supported? There's a positive or a negative association. This is really getting at DOFs, remember direction, form, strength, but this is not a scatter plot, okay? Categorical data, which is what this is, it doesn't have a positive slope or a positive association. Um, Maybe better, usually when we say association, we'd say there is no association or there is an association. Remember the chi-squared tests? You don't say positive or negative. C, the number of surveys given in the dining hall method was less than the number given in either of the other delivery methods. It doesn't say anything anywhere in here about the number of people. This could be 100 people, this could be 500 people, and this could be 1,000 people. It doesn't say, so it's not C. D, the psychology delivery method displays the most symmetric results. Other delivery methods were skewed. Again, this is categorical data. Kids are either they either yes, they returned it or no, they didn't. Only quantitative data can be skewed. Categorical data cannot be skewed. And then, so it's E. The class delivery method that had the greatest rate of return was the in-class. And that's this one right here. That's it. And the dining hall was the least, which is this one. So, woo, we did it. Goodbye.